Welcome to my channel. This is CCNA Essentials. This channel aims to provide a comprehensive course on the most essential knowledge required for the CCNA certification. In the last video, I discussed subnet calculation. Today, I will continue the topic of subnetting and provide scenarios for you to solve. The final part will cover advanced subnetting calculations. Scenario 1. Divide the network 192.168.1.0/24 into subnets with a mask of 25. Find the total number of subnets and the number of hosts in each subnet. To divide the network 192.168.1.0/24 into subnets with a mask of 25, we need to borrow 1 bit from the host portion of the IP address to create subnets. To calculate the number of subnets, we can determine the number of possible values for the subnet bits. In this case, we have borrowed 1 bit, so the number of subnets would be 2 to the power of 1, which is 2. To calculate the number of hosts in each subnet, we need to determine the number of available host addresses. Since we have borrowed 1 bit, the number of available host addresses would be 2 power of 32 to 25, which is 2 to the power of 7, equal to 128. However, we need to subtract 2 from the total number of hosts in each subnet to account for the network address and the broadcast address, which cannot be assigned to individual hosts. So, the number of usable hosts in each subnet would be 128 to 2, which is 126. Therefore, when dividing the network 192.168.1.0/24 into subnets with a mask of 25, we would have 2 subnets, and each subnet would have 126 usable hosts. Scenario 2. Divide the network 192.168.1.0/24 into 7 subnets, each subnet with 29 IP addresses. Step 1. Determine the number of borrowed bits. To divide the /24 network into 7 subnets, we need to find the number of bits required to create 7 subnets. Since 2 power of 3 is equal to 8, we need to borrow 3 bits. 2 power of 3 is equal to 8 greater 7. Step 2. Determine the new subnet mask. With 3 borrowed bits, the new subnet mask will be /27. 24 plus 3 is equal to 27. Step 3. Determine the number of IPs in each subnet. With a subnet mask of /27, we have 32 minus 27 is equal to 5 host bits. Therefore, there are 2 to the power of 5, 2 is equal to 32, 2 is equal to 30 usable IPs in each subnet, excluding the network and broadcast addresses, greater than 29 IP addresses as requirement. Advanced subnetting calculation. In real life, while the /24 subnet mask remains relevant and widely used, larger subnet masks are necessary in many scenarios due to the increased demand for IP addresses. Example: divide network 10.1.0.0/16 to /19. Find the number of subnets, IP addresses in a subnet, and network address for each subnet. Number of subnets, 2 power of 19 minus 16, equals 8. Number of IP address in each subnet, 2 power of 32 minus 19, equals 2 to the power of 13. How to calculate network address for each subnet? Assume x equals 32, new mask equals 32 minus 19 is equal to 13. We have a table to calculate x. X is in the range from 8 to 16. Then, we apply x in the second spot of the table. 2 power of 13 minus 8 equals 2 to the power of 5 equals 32. Therefore, the network address will be changed every 32 units at octet 3. Here is the list. That's all about subnetting. Thanks for watching. If you found this video helpful, please give it a like and subscribe. Thank you.